Picture a summer day, solar panels everywhere, turning sunlight into clean electricity. The grid hums with energy, powering our lives. But as the sun sets, those panels stop working. Suddenly, demand is high, but supply from renewables drops. This is the challenge. How do we store daytime energy for nighttime use? We need a giant, rechargeable battery, one built for cities, not just gadgets. Enter the Redox Flow Battery, a scalable, safe, and long-lasting solution. Think of it as a massive energy drink for the grid. These batteries can power entire neighborhoods, unlocking the full potential of solar, unlocking the full potential of wind. They're the missing piece for a 100% renewable future. Today, we'll step inside the factory where these energy giants are made. From raw materials to finished product, we'll see how science and engineering come together. This isn't about small batteries, it's about building the backbone of a clean energy world. So, grab your virtual hard hat. Let's discover how Redox Flow batteries are changing the game. The journey to a cleaner future starts here. What makes a Redox Flow battery different? Unlike lithium-ion batteries, flow batteries store energy in tanks of special liquid electrolyte. The amount of energy depends on tank size, not the battery itself. Want more storage? Just add bigger tanks and more liquid. 2 tanks hold positive electrolytes, 2 tanks hold negative electrolytes, separated until needed. When power is needed, pumps move the liquids into a central cell stack. Inside, the liquids flow past each other, separated by a thin membrane. Ions pass through the membrane, creating an electrical current. To recharge, the process reverses. Solar power pushes ions back, wind power pushes ions back, recharging the liquids. The power output depends on the size of the cell stack. Energy capacity depends on tank size. This means you can scale power and energy independently, a huge advantage. Flow batteries are flexible, perfect for the grid's changing needs. They're designed for safety, long life, and easy expansion. No more one-size-fits-all batteries, these are custom-built for any job. That's why utilities are turning to flow batteries for reliable, clean energy storage. It's a simple, elegant solution to a complex problem. The future of energy storage is flowing literally. Let's see what makes the heart of these batteries beat. The secret sauce of flow batteries is the electrolyte, usually made with vanadium. Vanadium is special. It can exist in 4 different electrical states, so both tanks use the same element. This means less degradation and longer battery life. The process starts with vanadium pentoxide mixed into acid and water in giant tanks. Precision is key. The right concentration and purity ensure efficiency and safety. The solution is charged electrically, splitting it into positive forms and negative forms. After filtering and stabilizing, the electrolyte is stored in massive tanks, ready for action. Unlike other batteries, vanadium electrolyte can last decades without losing capacity. If a little crosses over, it's still vanadium, easy to rebalance. This durability makes flow batteries a smart, sustainable choice. Next, let's see how the battery's core components come together. The cell stack is the heart of the flow battery, made of membranes and electrodes. The membrane is a thin, high-tech polymer, strong enough to separate liquids, but lets ions pass. It's crafted with microscopic channels, allowing only the right particles through. Each membrane is inspected for flaws. Quality is everything. The electrodes are carbon felt pads, offering huge surface area for reactions. Treated for maximum efficiency, they soak up electrolyte like a sponge. More surface area means more power and faster reactions. Special treatments make the carbon even better at its job. Once cut to size, membranes and electrodes are ready for assembly. Close up. Together, they turn chemical energy into electricity, cycle after cycle. This careful engineering is what makes flow batteries reliable and powerful. Now, let's see how these parts are built into a working battery. Assembly begins in a spotless environment. Assembly begins in a spotless environment. Workers and robots layer bipolar plates, electrodes, frames, membranes, building up the cell stack. Dozens or hundreds of cells are compressed into a single, powerful unit. The energy is stored in huge, durable tanks, sized to fit each customer's needs. Pipes, pumps, connecting everything, circulating electrolyte through the system. The balance of plant tanks, pumps, pipes, controls is as vital as the cell stack. Industrial pumps move the liquids, sensors and software monitor every detail. The control system manages charging, discharging, and safety. Once filled and connected, the battery is ready for its first big test. Let's see how it performs under pressure. Every battery faces a tough boot camp before leaving the factory. Electrolyte is tested for purity and performance. Membranes are tested for purity and performance. Electrodes are tested for purity and performance. Assembled stacks are cycled, charged, discharged, to check for leaks, to check for hot spots, to check for faults. Tanks are pressure tested, pumps are pressure tested, sensors are calibrated. The control system is put through safety drills. Only batteries that pass every test move forward. The entire system is then run through full-scale cycle testing, simulating years of use. Data is logged and analyzed for any sign of weakness. Only after passing this final exam is the battery shipped out, ready to power a cleaner world. Quality isn't optional, it's essential. Flow batteries scale easily, just add bigger tanks or more cell stacks. Need to store solar energy overnight? Use huge tanks. Need quick bursts of power? Build a bigger stack. This flexibility makes them perfect for towns, factories, entire regions. Communities gain energy independence and resilience. Storing local wind power, storing local solar power. During emergencies, flow batteries keep critical services running, with long lifespans. And recyclable vanadium. They're a smart investment. They make renewable projects more reliable and profitable. Flow batteries are accelerating the shift to a stable, clean energy future. Flow batteries aren't perfect, vanadium is costly, and prices can swing. Scientists are racing to find cheaper, abundant alternatives, iron organic molecules. Automation and AI are making factories faster and more precise, cutting costs. Smarter control systems are integrating batteries with solar wind weather forecasts. Modular designs are bringing flow batteries to smaller sites, remote communities. The technology keeps evolving: better materials, smarter manufacturing, wider use. From raw powder to powerful machines, flow batteries are solving the clean energy puzzle. They're not just clever engineering, they're the key to a reliable, renewable grid. As innovation continues, these giants will power our world safely for generations. The future of energy storage is here, and it's flowing.